Okay, so this is 15.2, multiplying and dividing rational expressions. We're going to look at both those concepts, one multiplying and one dividing. So concept 1, multiplication of rational expressions. All this is saying is that if we have a polynomial, a rational expression, a fraction, times another fraction, we just multiply the top and then multiply the bottom. Okay, so that's going to be true even if our fractions look like polynomials. We would multiply the top times the bottom. Or sorry, top, bottom. Here are some steps that we could follow. So it says factor the numerator and denominators. Okay, so what we did in 15.1, where we factored stuff out to see if we could cancel, that would be our first step. So factoring the numerator and the denominator. Then we would simplify. Simplify just means to see if we can cross anything out. And then once we cross everything out that can be simplified, we then multiply whatever's left. And the reason we do this is if we were to multiply everything out in the beginning, we would end up with a really large answer that would have to be reduced. And it would be harder to reduce that larger answer than the two separate fractions. And you'll see that here. So we have two rational expressions, two fractions. Before we start multiplying together, we need to see if the first fraction can reduce or if the second fraction can reduce. We can also see not only if they reduce top and bottom, we could see if they reduce on the diagonal. Okay, but first we check numerator, denominator. So looking at the first one right here, could this reduce in any way? No. There's nothing on the denominator that would help us reduce that numerator. What about on this one? Can we reduce this? Yes, that 6 over 10 can become what? 3 over 5. Okay, so that's the first thing we can reduce. This is now a 3. This is now a 5. Okay, so we checked top and bottom for both. Now let's check the diagonal. So let's first look at this diagonal here. Is there anything that can reduce on this diagonal? What can reduce? The 5s, good. So now those 5s are gone. Anything else? The b's. So now that's gone. So what's left on this denominator on that second one if everything's crossed out?
A squared.
Well, we're just looking at just this part. What's left here if everything got crossed out?
1.
A 1. There's only a 1 here now. Okay, now that we checked that diagonal, we have to check the other diagonal. Is there anything that can reduce on that diagonal? We have a 2 and a 3a. Nope. Now that we simplified everything is when we multiply across. So we have, and let me just write this out in an extra step so we could see what's left. We have a squared over 2 times 3a over 1. Okay, that's everything that's left on those two fractions. If we were to multiply across, we would get what on the top?
3a squared.
3a cubed, because we have another a there, over 2. That's our answer. So we're reducing top to bottom, then both diagonals, before we multiply or divide. Any questions on 1? Okay. Okay, we're going to do the same thing with number 2. We're first going to see if we can reduce each fraction separately. Okay. So focusing on this first numerator, is there anything we can factor out? a 3. So we would have 3 and then C minus D. Okay. That would actually... Okay, now we factored out that numerator. Now let's look at the fraction as a whole. What can we reduce? So we're looking at this whole fraction right here. Anything that can reduce?
3 over 6 to 1/2.
Good, 3 over 6 can reduce to 1/2. So this is now a 1, this is a 2. Okay, we can't cancel out the C just yet because 1 is just a C, and on the top it's a C minus D, so they're different. Okay, now that we simplified that first one, we got to go to the second one and see if we can simplify. So on that second fraction, which one would we try to simplify, the top or the bottom?
Denominator.
The denominator. So what does this denominator look like?
-1 C squared minus D squared.
Close, but notice since both of them are squared and they're separated by a minus, this is what type of factoring? Perfect square. So that means instead of C squared minus D squared, I could write this as what? C minus D and C plus D. Okay. Now looking at this fraction as a whole, is there anything else I can reduce? No. So I already checked the top and bottom of the first one and then the top and bottom of the second one. So what's my next step? The diagonal. So looking at this first diagonal here, what can I cancel out? C minus D. Okay. Now looking at this diagonal, what could I cancel out? The 2's. Okay. Now we multiply whatever is left. So on the first fraction's numerator, we have a 1. And on the second fraction's numerator, we have a 1. So 1 times 1 is 1. What's left on the first denominator? 1C, or we could just write C. And what's left on the second denominator? So we would just write C times C plus D. We don't have to simplify this further because we want it as factored as possible. So you wouldn't multiply the C back in. You would leave the C on the outside. So we reduce each fraction, then we reduce on the diagonal. So that was the concept for multiplication. It's going to be the same concept for division, except we don't multiply across. When we divide, what do we have to do to that second fraction? Flip it. We have to do the reciprocal. So for concept 2, division of rational expressions, we have to take the reciprocal of the second fraction. Then we multiply. Okay, that's the only step that's changing. Just like when we're multiplying and dividing regular fractions. Okay, so we flip the second fraction. So before we start simplifying, we're going to rewrite this in terms of multiplication. So this is going to become 5t minus 15 over 2 times the reciprocal of that second fraction. So 10 over t squared minus 9. Once I take the reciprocal of that second fraction and I have it in terms of multiplication, then I move on to the steps we were doing before. So I have to make sure I do this step first. Now I'm going to reduce. So looking at the first fraction, what can I reduce? Just the first fraction. Good, I could take out the 5. So then this would become 5t minus 3. Okay. Anything else that I can do with that first fraction? No. Now I move on to my second fraction. What could I do to my second fraction? So I can't do anything with that 10. But what about the bottom? Good, I could factor that because it's a what? Perfect square. So this becomes t minus 3, t plus 3. Anything else I can do with just that second fraction? Okay. Now that I simplified both fractions separately, then I can look at what? The diagonal. So I'm looking at the diagonal here first. What can be canceled here? T minus 3. And then on this one, how could this be reduced? It could be divided both by 2, so I would have 5 here and 1 here. Okay. Now that I have everything reduced, what do I have left on both numerators? A 5 and a 5. So 5 times 5 is 25. And what do I have left on both denominators? Good, I have a 1 and a t plus 3, which would be t plus 3. That's my answer. So I have to first flip my fraction, reduce each fraction separately, reduce on the diagonal, then multiply. Any questions? Let's look at number 5. So number 5, we're going to have a lot more factoring to do. Okay? But before we do any of that, what am I doing to my second fraction? Flipping it. So rewriting this, I have p squared minus 11p plus 30 over 10p squared minus 250 times 2p plus 4 over 30p minus 5p squared. Okay, so all I did was flip my second fraction. Now I'm going to be reducing one fraction at a time. So looking at the first numerator, what are we going to have to do? The AC method. Perfect. So AC method. So I have p squared minus 11p plus 30. AC method means a times c is what? What's a times c? 30. And what's my b value? Negative 11. So what two factors? Good. 6 and 5. Does 6 and 5 positive or 6 and 5 negative? Negative. Negative 6 times negative 5 gives me positive 30. Add them together, I get negative 11. So that means I have my factors of p squared minus 6p minus 5p plus 30. Now what factoring am I doing? Grouping. What can I factor out of the first one? P, and I'm left with p minus 6. And then what about the next one? Negative 5, and I'm left with p minus 6. So I have p minus 5 and p minus 6. That is what's going to go into that numerator spot. Okay. What can we do with the denominator part? Good, we could take out a 10, so I have 10p squared minus 250. If I take out a 10, I'm left with p squared minus 25. Can that reduce further? Why? What is that p squared minus 25? Perfect square. So I have 10p minus 5, p p plus 5. That is going to go in the place of that denominator. Okay. Now looking at the other numerator. Okay. We have that 2p plus 4. What can we do with that one? Take out a 2, and I'm left with p plus 2. And then lastly, what can I factor from 30p minus 5p squared? I could take out a 5p. Let me first rewrite this, though, in the correct way, because this should be negative 5p squared plus 30p. So I could take out a 5p, but I also would want to take out a negative. So I would take out a negative 5p, and I would be left with p, what? Minus 6. Minus, because negative 5 and negative 6 would give a positive p. So again, these are all the things that I am going to plug back into my original problem. So I have everything factored. So plugging that back in, I had p minus 5, p minus 6 over 10p minus 5, p plus 5 times 2p plus 2 over negative 5p, p minus 6. Okay. Now we're just looking at this part. This is everything that we reduced, rewrote it into my fraction. So looking at the first fraction, is there anything that I can reduce? Just the first one. P minus 5. Okay. Anything in the second one, just the second one? No, right? There's nothing we can do in the second one. So then we're going to look on that first diagonal. Can we cancel anything on that first diagonal? Good, the p minus 6. Anything on the second diagonal? So remember, we're looking at this diagonal now. Anything we can cancel on this diagonal? The 2 and 10. So the 2 becomes a 1 and the 10 becomes a 5. So now that I have everything reduced, what do I have left on the top, the numerator, if I multiply across? P plus 2. And then what about the bottom? But remember, I still have this p plus 5 too. So I have 5 p plus 5 times a negative 5p. So if I reduce that denominator, I have what? What's 5 times negative 5? Negative 25p, and then p plus 5. This is our answer. So for these type of problems that required every single part to be factored, I would have to see the factors for each part, then see where you put it back together, and then see what you're canceling. This would be the longest type of problem for this concept, where each one is factorable. Any questions so far? Okay. Now let's look at number 6. So number 6 looks like we have a fraction over another fraction. So a fraction in our numerator and a fraction in our denominator. We could rewrite this division bar here as just a division symbol. So we could take this and we can say this is the same as saying 3x over 4y divided by 5x over 6y. That looks less intimidating than that giant fraction. Okay, so I didn't do anything to the problem except rewrite it as a fraction divided by another fraction. But since we can't divide and we need to multiply, what's going to happen to that second fraction? Good, it's going to flip. So I'm left with 3x over 4y times 6y over 5x. So our first step is to see what simplifies first.
X and Y.
Well, first we're just looking at each fraction, right? Can that simplify that fraction?
No.
Nope. What about this fraction? Nope. So then we look at what? The diagonals. So in this diagonal, what can cancel out? The x's. Okay, and then the other diagonal, what can cancel out?
Y.
The y's and anything else? The numbers can be reduced to what?
2 and 3.
2 and 3. If we divide both of them by 2, this 6 becomes a 3, this 4 becomes a 2. Okay. Now that we have everything reduced, we multiply across. What do I have in both numerators? 3 times 3, which is 9. And what do I have in both denominators? 2 and 5, which is 10. So I have my answer of 9/10. So very important to separate them like this if you see them in one large fraction, because this can become confusing. Just know that if we have a fraction over another fraction, that fraction bar can be written as a division sign. Now we have problems like number 7 where we have division and we have multiplication. So in these type of problems, we want to break it apart step by step. So what we're going to deal with first is just these first two fractions. So we're only doing this first. Okay? Which means since we're dividing, what do we have to do to that second fraction? Flip it. So I have 4 over c squared minus 9 times c minus 3 over 6. We're only doing this part first. Okay? Looking at the first fraction, can we simplify that in any way?
Yes.
Yes. How can we simplify that c squared minus 9? Good. C plus 3, c minus 3. Can we reduce that second fraction in any way? Nope. So that means now we look at the diagonal. So looking at the first diagonal, how can we reduce 4 and 6? 2 and 3. And what can reduce on the next diagonal? Good. So that means if I was to multiply this across, I have 2 times 1, because there's nothing left there, so I have 2. And what's left on the bottom? C plus 3 and 3. So we do 3 times c plus 3. Is this our answer? No, because we still have to do what? We still have to multiply 3c over 8. So I'm going to rewrite this as 2 over 3 times c plus 3 times 3c over 8. So remember, first we look at each fraction separately. So in the first fraction, can anything reduce? No? What about the second fraction? No? What about the first diagonal? What would that reduce to? 1 and 4. What about the second diagonal? So can I cancel out the C's?
No.
No, because one of the C is C plus 3. That's all together. It's not the same as just saying C. So that means the only thing I can cancel is what? The 3. So that means my answer, what do I have left on the top? Just C. And then what do I have left on the bottom? 4 and C plus 3. Good. So that's my answer. You can try to flip the second fraction and have this one long multiplication fraction, but that's more room for error. Okay, so it's easiest just to break it up, do the first two, get an answer, then add the third part in.
Question though.
Yes.
In this one, if you were to factor the 3 to the C plus 3, you would then have a 3C. Would you not be able to factor that whole bit out? Like the 3C and the 3C?
Okay, so that's a good question. So the question is this: if we were to multiply this back in and we get 3C plus 9, am I still able to cancel out a 3C with this 3C? That answer would be no,
It's plus.
because it's attached by a plus, not multiplication.
Gotcha.
Okay, so that's a good point. Yeah, we can only cancel these things out because notice everything we're canceling out is being multiplied by each other. So we're able to cancel. Yes.
That second fraction, would we flip that one? Or just leave it like that?
For
Like the 3C might not
oh, the 3C over 8, we would leave it this way because if we look at the original problem, it's being multiplied. And since it's being multiplied, we don't have to flip it. Only when it's being divided. Okay, good question. Any other questions so far?